Okay, the chain rule is another option that we can use to differentiate a function of this form, which is just a reciprocal 1 over, but of course not just x on the bottom, a trapped function on the bottom, which of course is x squared plus 3x plus 2. So to this point we would have used the quotient rule, which maybe we'll do so we can contrast both methods, and they're both probably similar in time and difficulty. So let's differentiate this function with the quotient rule, which, if you remember, is the bottom function multiplied by the derivative of the top, and then we realize the derivative of the top is 0, so that is all going away in a few more seconds, and then minus the top multiplied by the derivative of the bottom, which is 2x plus 3, and that is all over x squared plus 3x plus 2. Now remember, you have to square your bottom in the quotient rule. And let's just write that a little more compactly as minus, don't forget that minus, and you can multiply that through if you wish. This minus times 2x plus 3 all over this trapped quadratic, which is now squared. X squared plus 3x plus 2 squared. So there's our derivative via the quotient rule, which was not too painful, because of course this all disappeared. So we only needed half of our numerator there. So let's just look at probably a similar difficulty level is how can we differentiate that same function using the chain rule. Well, we're going to rewrite it with a -1 exponent. So we don't have a top and bottom or a numerator and denominator anymore. We're just going to interpret our reciprocal, of course, as a -1 exponent. And then our chain rule will tell us to differentiate the outer function, which of course is our power. So our power comes down and we subtract 1 from it. Our chain rule hopefully also tells you to keep that trapped function trapped in that outer derivative, and then we'll multiply it, the second link in our chain, by the derivative of x squared plus 3x plus 2. So differentiating via the chain rule gives us the same answer, which you may see already. Maybe we'll write this as a -1 on the top and move that negative exponent to the bottom. So this is going to be x squared plus 3x plus 2 now to a +2 power. And of course multiplying by the derivative of x squared plus 3x plus 2 is going to be multiplying by x squared. Sorry, not x squared. By 2x plus 3. And you can see that's just going to get tucked in the top, and of course that gives us exactly the same answer, and maybe the same number of steps, or pretty darn close to the same amount of time. And that's all over x squared plus 3x plus 2 all squared. So the chain rule is not necessarily better here, but it's an option, and just so you know that you can take either option and both will give you the same derivative.